All right, so looking at example number 6 for implicit versus explicit functions, we're going to say given implicitly defined functions, so each of these functions here are implicitly defined, we're going to solve each one of these functions for y in terms of x. And we're going to state whether the equation represents y as a function of x, basically whether it's a function or not. So we have a bunch of relations here in implicit form. We're going to rewrite them into explicit form first and then say whether or not it's a function. So for part A, we have 2x plus 3y equals 5. Let's solve for y, and we'll determine whether or not this is a function. So getting y by itself on one side, I end up with y equal to 5/3 minus 2/3 x. This is just a line, the equation of a line in y equals mx plus b form, basically, or b plus mx form in this case. And we know that a line is a function. And why is that? Well, in this case, we're looking at the algebraic form of this function. Basically, if you look at the x value, is there any x value that I can put in here for x that will give me a y value and also a different y value? Can I get two possible y values out for a single x value? No, if I plug in, say, 1 into this equation, right, and I get y is equal to 5/3 minus 2/3 times 1, right, which is going to be equal to 3/3 or just 1, right? I only get one answer from plugging in that value 1, my x value. And that's going to be the case for every x value. So therefore, this is a function. All right? Now if we look at part B, right, we have x squared minus 2y is equal to 3. Let's solve for y and determine whether or not this is a function. All right, so getting the y by itself, we get y is equal to x squared over 2 minus 3 over 2, right? Do I have the same situation as I had before, where I plug in an x value and I get a single y value, or can I plug in a single x value and get two possible y values out, right? Test it out. If you plug in, say, 1 for x squared, let's plug in 2. It might be a little bit, no, let's plug in 1. Plug in 1 for x squared, you get y is equal to 1 squared over 2 minus 3 over 2 is equal to negative 2 over 2, or negative 1. I got one y value for my one x value, right? I didn't get negative 1, but then also 2 or something like that, right? I only had that one y value come out. Therefore, this is a function. All right? Remember to box your explicit form as well. That's part of the answer. Now, what about part C? If I solve for y, what do I get? I get y is equal to 1 over x. But what happens if I plug in a value for x? Do I get more than one value, more than one answer? No, that'll never happen, right? And you can see if you test a couple of values, you'll always only get one answer for y for every one value of x. So this is a function. And then looking at part D, let's solve for y, and then determine if that's a function. All right, so solving for y, we get y is equal to plus or minus the square root of 4 minus x squared. And that plus or minus actually comes from when I take the square root of both sides here, right? Then essentially what happens is if I do the square root of 4, for example, what is that? Well, it's 2, but it could also be negative 2, right? Because negative 2 squared is positive 4. So whenever I do the square root of something like this, I do a plus and a minus in front of it because it could be either positive or negative, right? So in this case, I get a plus or minus. If I put an x value here and plug it in for x, say like 1 or something like that, then this plus or minus, what it does essentially is it says you're going to get two answers for y. I can get a positive answer or I can get a negative answer, right? And that's not okay for functions, right? If I plug in a single value here for x, I cannot get two answers for y, right? That would not be a function. So in this case, we do not have a function. All right, and then finally, example number 7, to finish out these guided notes. We want to find the domain of each of the following functions, and we want to use a graphing calculator to verify our findings for the domain. So in order to graph these in our graphing calculator, we have to write these in explicit form. So the y has to be by itself because our graphing is the only thing our graphing calculators can read, right? So we have to solve for y in these problems and write it in explicit form instead of implicit form. All right, so for part A, we write that in explicit form and solve for y. Again, I did the square root of both sides here, right? And so I get a plus or minus in front of my radical sign. Okay, so now I'm going to graph this. And again, remember we said the plus or minus for y is giving us two answers for y. So this is not going to be a function. This is only a relation. But we can still graph this, right? We're just going to graph two different things. So let's graph positive square root of x squared minus 9. And then we'll graph as well negative square root of x squared minus 9. So first, positive square root of x squared minus 9. What does that look like? Well, if you graph that on your graphing calculator, it should look something like this. So we have a couple of slant asymptotes here, right? And our graph passes through the point 3, 0 right here and negative 3, 0 right here. All right, so looking at our equation, what is the domain going to be for this equation? So basically, what can my x values be? Well, I have a square root, so that's a big red flag, right? What can I do the square root of? I cannot do the square root of a negative number, right? So I know that x squared minus 9 has to be positive or equal to 0, right? So let's solve for x. I know then that x has to be greater than, or x squared has to be greater than or equal to 9, or x has to be greater than or equal to 3, or x can be less than or equal to negative 3, right? Now just plug in some test cases to test and see if that's true. Basically what that means is I can't have anything between positive 3 or negative 3 for my x. Is that true? If I put in 0, for example, right? I get 0 minus 9 is negative 9, and I can't do the square root of negative 9, right? So it looks like that's true. That's the case, right? So then my domain is going to be, in set notation, everything less than or equal to negative 3. This is a special type of set notation using parentheses. This is not an ordered pair. It means that I'm looking at everything from negative infinity, that means to the left forever, all the way up to negative 3, but I'm not going to include negative 3. That's what the parenthesis means. If I put a bracket, that means include negative 3. Right? So actually, in this case, I do want to include negative 3, right? So actually, the way that I wrote it initially was incorrect. This is what it should be, including negative 3 with a bracket, right? But then I also want to include x is greater than or equal to positive 3. Now, how would I write that? I'm going to start at 3, and it's going to include it, and I'm going to go greater than or equal to 3, right? So forever greater than 3 to infinity. And you always put a parenthesis around infinity. And then I want to join those two. All right, and then I want to join those two. So to join them, I put a U between them for union. All right. Okay, so what this means, again, is for my domain, I'm looking at everything going all the way up to negative 3 and including negative 3 because of the bracket. I'm going to stop there. I'm going to do a union. I'm going to skip over to positive 3, right? Include positive 3 with a bracket, and then go on forever after positive 3. That's what that bracket notation means for the domain. All right, and then you can verify that on the graph as well. So we can look at, for our domain, it's going to be all the x values. So let's just go along the x-axis. So we start at negative infinity, go along to the right. It hits negative 3, right? And then it stops. And then it jumps over, and then picks up again at positive 3, and then goes on forever after that, right? So that verifies our domain here that we described. All right, what about part B? Well, part B is already written in explicit form, so we could graph that, right? F of x is the same thing as y, so you can plug in x squared plus 4x into your calculator, right? And then we want to first determine what the domain is from this algebraic expression, right? So what can x not be? Is there anything that x cannot be? Or can x be any possible number? Well, there's no square root, there are no fractions, nothing weird that has any rules applied to it here, right? So x can be anything, right? So for this, I can say that my domain is going to be every number. So from negative infinity all the way to positive infinity, all the way to the left, all the way to the right on my axis. That's going to be my answer from my domain. Another way to write it another set notation way to write it would be the set of all x, where x is an element of the real numbers. But you'll see that more in more advanced mathematics, not so much in this class, but I just wanted to point that out. It's another way to write it. All right, now what would the graph of this look like? Graph it on your calculator, and it would look something like this, right? It's a parabola, and we can look at the domain of this parabola, right, to verify that we were correct from our algebraic representation for a domain down here. Let's verify that we're correct, right? If we look at the x values, what do we get? So we go from the left, from negative infinity, right? Where does my my graph here end? Does it end or jump at any point? No, it keeps going, right? So it keeps going, looks like it keeps going forever to the right, right? So it goes forever from the left, and it keeps going forever to the right. So it's all values, right? This is what we got right here. Everything from negative infinity to positive infinity. Looking at part C, we want to look at the domain of this algebraic representation of a function, right? So we're going to say, what can x not be? To find the domain, we always say, what can x not be? We have a fraction, right? And what's the special rule about fractions here, right? We cannot have 0 in the denominator. So we know that x squared minus 4 has to be greater than or cannot be equal to 0, right? Cannot equal 0. So I know that x squared cannot equal 4 if we solve for x. And take the square root of both sides. X cannot be 2, and x cannot be negative 2, right? But x can be anything else. So then I know that my domain is going to be all numbers start on the very left, all the way from negative infinity, and we're going to stop at negative 2. Can it equal negative 2? No, it cannot, right? If I plug that in, then I get 0 in the denominator, right? So I cannot equal it, so I'm not going to put a bracket, I'll put a parenthesis. Cannot equal negative 2, right? And then I'm going to skip that point, and I'm going to pick up again, not including negative 2, right? I'm going to include all the numbers between negative 2 and positive 2, but not including positive 2, right? Because that was one of the things that x cannot be. And I'm going to skip that positive 2, and then jump back over, not including positive 2, and all the way to infinity. All right? So that basically says all numbers except 2 and negative 2. And make sure you understand that because you'll be expected to be able to write this in this notation on exams. Now let's verify that graphically. If we graph this on our graphing calculator, what does it look like? Well, it would look something like this. Right, so we have a couple of vertical asymptotes at negative 2 and positive 2. It's because x cannot equal those. And we have also a horizontal asymptote here at y is equal to 0. We have this horizontal asymptote. Right, so if we look at the domain, what can x not be? What's going on with x? Well, it looks like we're going from negative infinity. We can follow our graph, right? All the way from the left, and then we hit a point here where my graph jumps, right, at 2. So we skip over 2, but then we can pick up again right after it, right? Keeps going. We hit 2 again here, and we have to jump over it, right? This graph jumps again and keeps going on forever. So that's exactly what we said down here. We have 3 different intervals, right? 1, 2, 3, and those are described by these 3 different intervals here, right? Where each of these guys right here are little jumps. And then finally, part D, we have a square root, right? So we want to find the domain. We have the special, we have a square root which has special rules. We cannot do the square root of a negative number, right? So I know that 3 minus 4x has to be greater than or equal to 0. Right, so let's solve for x. I get 3 is greater than or equal to 4x. So then 3/4 is greater than or equal to x. Right, so x, and if we flip it around, is less than or equal to 3/4. All right, so that's telling me that my domain is essentially everything less than or equal to 3/4. So how do I write that in set notation? Well, I'm going to start at negative infinity. I'm going to go all the way up to 3/4, right? And I'm going to include it because it can be equal to it, right? So I'm going to put a bracket there, not a parenthesis. That means including 3/4, and that's it. That's my domain. Now let's graph it real quick and figure out if we can validate that through our graph. So what would the graph of this look like? It would look something like this, right? And so we can validate it by saying we start at negative infinity, start going to the right, following our graph, right? And our graph is going to hit right here at 3/4, and it stops. It does not go on anymore, right? And that's exactly what we said here for our domain. It goes from negative infinity to 3/4, and then it stops, but including 3/4. So our graph validates what we initially found.